Hello and welcome to this lecture. In this lecture we're going to talk about object-oriented programming, referring specifically to classes, objects, attributes, and methods. So, let's remind what is our case of study for this first model. We're working on specifying Luke's agenda. As we can remember, Luke wants to manage the information of his agenda, which currently has numbers of his 3 friends. We refer to Miguel, Laura, and Alex. For this purpose, he has hired our course to analyze and design a possible solution for his problem. We know that he wants to be able to first register the name, address, and phone number of each of his friends. Second, he wants to access the data of one of his friends by her name. And third, he wants to get a list of his friends' names and phone numbers. Of course, we have the restriction that we have already been talking about from the previous lectures. Any possible solution must be developed using Java as a programming language, and also with a budget limited to 2 M&Ms, because, well, this is the currency that we're using for paying software in this context. So, based on this context, in which we have already identified different functional requirements and non-functional requirements, a part of the elements that we know that are happening in this context, which are the agenda and the friends, we get to paint the world's model for this project. For this, we're going to use UML, which is the Unified Modeling Language that we will be using throughout the course, as you have already seen. We have 2 elements happening in the context that are managed and modeled as classes. So we have the agenda, which is the bigger class, and we have the friend, which is the smaller class. So the first step, whenever you get to have a context and try to model using this diagramming language, the first step is to identify the elements that are going to be modeled. So here we have the agenda and we have the friend. We also know that there is a relationship happening within the agenda and the friend, between the agenda and the friend, So we have 3 friends that we know their names are Miguel, Laura, and Alex. So we know that the agenda has 3 elements of type friend that are referring to the type friend. So in this case, every friend is going to have the properties that are appearing in the class. So every friend is going to have a name, it's going to have an address, and it's going to have a phone number. Also, we get to have responsibilities. The responsibilities in the bigger class are referring to the functional requirements. We get to see them: add new friend, search friend by name, and also get list of friends. And in the case of the class friend, we get to see the responsibilities referring to the data that is managed by the friend, the name, the address, and the phone number, and how accessible are that data from the class that is able to look at this class. So we get to see that from the friend perspective, anyone who has a friend is going to be able to get the friend's phone number, get the friend's address, get the friend's name, and is also going to be able to set the name, set the address, and set the phone number using input data corresponding to each and every one of these methods. So this is the first thing that we were discussing in the previous lectures. We also get to see that we have some getters and setters happening in agenda. Well, we only have getters. We have get number of friends, which corresponds to the attribute that we know that is the number of friends, existing friends in the agenda. So whenever we get to put an element in each of these slots, this number is going to increase by 1. That's what we're managing here. We also get to have get friend 1, get friend 2, and get friend 3. if we see there is a difference between the getters of this attribute and these associations. So we get to see that from get number of friends, we're returning an element of type int. We're returning an integer number. But when it comes to return get friend 1, get friend 2, and get friend 3, we're returning elements of type friend. So we are referring to these objects, returning objects of the type friend. So it means that the returning element here is going to have a name, an address, a phone number, and a set of responsibilities. That's what we get to see here. So, let's start identifying elements and some of the concepts that are covered using this UML language, this diagramming language. So the first thing is that, if you get to see here, we have name, address, and phone number. Name, address, and phone number, they share to be part of the class friend, but if you get to see only name and address, get to have a type, a string, while the phone number is an int. So, if we see here, what's happening is that the name and the address are going to be modeled as text. The phone number is going to be modeled as a number, a numerical element. Also, we get to see that the string corresponds to an S in capital letter, while the int is referring to the first letter, the I, in a lowercase. So, this is the first thing that I need you to observe when it comes to use Java and other high-order programming languages. We refer to primitive data types using the lowercase. And you're going to see that compound data types generally begin with a capital letter. Also, we are observing in this class, friend class, that there is a minus and there is a plus. If you get to see, the minus is referring to the properties. That means that those properties are going to be private. When we say private, what we're saying, nothing else and nothing more, that these properties, these attributes, are only going to be accessed and managed by the class that has them. In this case, if you get to see name, address, and phone number as data values, are going to be managed only and exclusively by the class friend. This is different when it comes to talk about the methods or responsibilities that we have here in the lower box. The responsibilities here are public. That means that any class that has knowledge of a friend is going to be able to access these methods. This is cool because what we're saying here is that the class friend at the very end is going to be responsible of operating. It's going to be responsible of giving access or denying access to those classes that know the class friend. So, let's see, for example, a situation using Facebook. Let's think about this. So, if you have used Facebook, or if you have used a social network as Instagram or as Twitter, you know that you have the possibility of making things public or private. So let's imagine, for example, that on Facebook, you're making your friend list public. If I wanted to see how many friends you have, and and that list is public, I don't need to ask you. I don't need to pick my phone and call you. I don't need to text you and ask you. I just need to look at it. It is public. It means that I don't need to ask for your permission to access, see, and maybe operate with that data. But if you make your friend list private in a social network, it means that if I want to see how many friends you have in the social network, in your account, I need to ask you. I need to request for that information. It's the same thing that is happening here. I can request you to operate on your data. That's how we're managing here the access. That's how we're managing what is public and what is private. If this data were public, it means that I don't need to ask you to operate on it. But because the data here is private, I need to access it, asking you to operate on your data. At the very end, the operations are happening in your class, on your data. That's how this is being managed. So, let's observe what else do we have here. We have data types. I'm sorry, right here, let's go back. Perfect. So we have data types that are simple or primitive, and we have data types that we understand as compound. Data types that are simple are data types that come with a programming language, and that are data types that are not built based on other data types. So we have, for numbers, we have the integer, referring to integer numbers. We have for real numbers the double. I know that some of you have already expressed that you have previous knowledge on programming. There are other data types to model this kind of numbers. For example, when it comes to integer, we also get to have short and long. And the difference between short and long is actually how much size are we giving in memory for that data value. When it comes to real, you're also going to find the float data type. Float and double are generally the ones that we use, and the difference is also the same. How we represent the data value in memory. These two that I'm proposing here are the initial ones that we're going to be working with for the process of this first model. Why I'm not introducing you to other data types? Because I have experience teaching introductory programming courses, and I can tell you is that when you get to put much more flavor, when you get to put much more information, concepts, somehow that's disruptive. And somehow that generates more like noise than actual sound. So here we're going to work with these two, and according that you get to evolve in your programming skills, we're going to get to introduce more data types. The question that I know that some of you might have in your head is, what is a data type? A data type is like an envelope. So we have a value. The value is the data. So we have a value, for example, referring to your grade. Let's think about this. So the value can be represented as a number, can be represented as a true-false statement, can be represented as whatever. When we put the data type covering that value, what we're saying is that that value is going to belong to a set of elements that somehow have the same properties. So the data type int, what we're saying is that any value that corresponds to a number that doesn't have decimals, just a number considered somehow an integer from our mathematical perspective, can be modeled as an int. When we say, for example, textually, that we're talking about a sentence, that we're talking about a phrase, a set of words, we say, yeah, that's something that we can model as a text or a set of words or a set or list of characters. That's something that we can consider a string. It's the way that we get to label the data values. So that's how we get to model, in this case, what a data type is. It's the set that corresponds or that covers or to which belongs the data value. We have that there are data types that are simple, so we refer to the int, to the double. We have the other ones that you don't need to learn them right now, but we're going to cover them throughout the course, that are short, long, float. And in the case of text, we get to have the simple one that is referring to the character, a char. This is the reason why, and this is very important because there is like a common understanding that any primitive or simple data type is the one that belongs to the programming language. But if you get to see Java, at least Java, is very explicit when it comes to refer to the simple ones and to the compound ones. Simple generally is model with the lower case letter. Compound, following the standard, begins with a capital letter. Char is actually the primitive, the simple data type that is used to build a string. A string is a list of elements of type char. So you get to see the word has characters. That's how this works. Also, when it comes to logic, we have the type Boolean. Boolean is the type that we use to express true or false. And it's the one that we're going to be using for this first model. So these two are the two big categories of data types, and we're going to keep working on this and to deep in the definition of these two concepts. Let's see what are key concepts generally used in Java. The first one is null. When we say null, we're referring to nothing. We're referring to a space in memory that doesn't have any kind of value. It is better just to think of it as a nothing. So when we have the null, what we're saying is that in memory there's no reference to what you're looking for. As simple as that. So when you have something that is null, you get to have errors referring, for example, the null pointer exception. I know I did it on purpose for the first assignment. You have a method that I'm pretty sure is already outputting the null pointer exception. And it happens when, for example, you say, hey, friend 1, I would like to get your name, and there is no friend 1. So think of the null as if you have a shirt. Let me see. Let's see an example right here. Right here, we have a chair, our chair, right here. So imagine that you just get somewhere. Let's think, for example, in a bus, or let's think, for example, in a train, or in an airplane. So you look at the chair, and you ask, hey, excuse me, can I get there? Yeah, it's hilarious. Nobody's responding to me. I'm trying to get data. I'm trying to get a response from something that is not here. That's the same that happens in memory. And what happens is that right here, this slot of memory is telling me that there's nothing happening here. You see? So if I get to us here, there is not going to be any kind of response because actually this is totally empty. So if I say, for example here, excuse me, sir, can I have your name? There is not going to be even an empty message because there is no message at all. The response is actually going to be an error that is going to be like, hey man, you're asking null to give you something. That's a null pointer exception. And that's something that you're going to get used to in Java when it comes to refer objects, their existence, and their actual representation in memory. If there is no instance, there is a null. As simple as that. We also have the word void. Let's take out our friend right here. We have the word void. Void is attached to the operations. We use void when an operation is not returning, is not having an explicit output. That's when you use void. So, for example here, we have the setters, set name, set address, and set phone number. Those were stated as void because I received the input, the string name, pname, and I just operate updating the current name to pname. I don't need to give a response. I just need to update the data. So in this case, because I don't need to give a response, and I don't want to in the context of this program. I just say that this method, setName, is going to be void. It means there is no returning statement. But there's a misunderstanding in the community sometimes, and it's that people get to think that void is a data type. Beware that void is not a data type. Void is not a way to refer to data values. Void is the word that we use just to say that a method, a responsibility, an operation does not have a returning statement. So, no, Java does not recognize void as a data type. It means that we cannot do this. This is incorrect. Void is only referring to methods, stating explicitly which method has no returning statement. Let's continue. How is the structure of a class? Let's begin with the class friend. In Java, you get to see generally we have class, opening brackets, and it's like when you have a friend, literally, and when you greet and you say goodbye. Whenever you greet someone, you need to say goodbye in order to be respectful to that individual. It's the very same that happens in these kind of classes and in this programming language. Whenever you open a bracket, you need to close it. Whenever you say hi, you need to say goodbye. So, in this case, we have the class, and we have class friend. Friend is going to be the name of this class, and if you get to see in our notation, we have F as a capital letter. What does it mean for us? It means that every class is going to become a data type, and it's going to be a compound data type. In this case, the data type friend is going to be built having a name, an address, both of type string, and a phone number of type int. Our class needs to begin with F capital letter because that's the notation that we use. So, we define the attributes corresponding to the first box here. So we have the access type. Is it private or public? We also have protected in Java, but we're going to see about protected later in the course. So far, I want to simplify this working as private and public. Private is something that is only accessed from the class. Public is something that can be accessed from outside. So we have private, we have public, referring to the methods, and we have the data type and the name of the attribute. So the attribute name is going to be of type string. The attribute address is going to be of type string. And the attribute phone number is going to be of type int. It means that these two attributes are going to be textual, and the last one is going to be numerical. We also have the constructor, the method responsible to initialize the attributes. Or, in other words, the method that we call to create an instance of type friend. Here we see that we receive a name, an address, and a phone number. And what is happening within is that the name is going to be equal to the value received as an input. The address is going to be equal to the value that we're receiving as an input. And the phone number is going to be equal to the value that we're receiving as an input. Very important. We need to have apples and oranges. If you get to see here, when we assign a data to the attribute, that data needs to have the same data type to the corresponding attribute. So a string with a string, a string with a string, and phone number that is synced with an int. That's the way that we get to find when it refers to a class. Important aspect. I know that you have already checked the skeleton that was shared for task 3 in the assignment, and the purpose of me giving you the assignment before giving you this later was for you to explore. This is also the way that you get to build a skill that is very important for any computer scientist that is learning how to learn. So, this is important. Whenever we have this, we're referring here to the description of the element. The description of the element, when it comes to talk about Java, you're going to see that there are going to be comments that are in green and other comments that are in blue, like these ones. Here we have 2 asterisks, and this corresponds to what we're going to see later in the course called the Java doc. This is the way that we get to give documentation and the way that we give information about the class and about its elements to other developers and other developing teams. Very important here, notation. This is a key point. We need to be a standard in the way that we code to have good practices, and also in order that other developers get to be able to understand what we're doing. So you get to see here, I'm being very descriptive in the attributes, in the elements, and also in the operations. You get to see. You can totally do, like, let's imagine, I went to watch X-Men, the movie. Yeah, the one Wolverine. So I say, hey, I don't want this to be called string name. I want this to be called private string Wolverine, private string Storm, and private in Professor Xavier. And I just give the description here. No, Professor Xavier is actually referring to friend's phone number. And Storm is referring to the friend's address. What is going to happen? What is going to happen is that there's going to be another developer that maybe doesn't have any idea of X-Men, and if that developer gets to read the code that we just described, it's going to be like, whoa, holy cow, how is that possible? What is this meaning? I have no idea. Whenever we code, we need to be descriptive. And that means that we need to provide sufficient information to other people that are going to interact with our code to understand. Because there's no developer, no software developer, no programmer working alone. Generally, we get to have more people interacting and building software together. So we need to be descriptive and clear, and that's why I begin with this kind of good practices, showing you example of good code using Java as a programming language. Let's continue to the class agenda. Oh, we're still in class friend. Yeah, the next one is agenda. So, in class friend, we have other methods. We have the getters, and we have, in this case, the getters, a string name, you see here, and phone number. And if you refer, the getters correspond to the data type of the attribute. So, if we are talking about the name is responding with a string. We have a method responding with a string. And in the phone number, we are responding with an int, which is the phone number right here. Again, important, the notation. If you see the methods begin differently from the constructor, the rest of the methods begin with a lowercase letter. This is notation. This is really important. The only method that begins with a capital letter is the constructor, which is the method responding to create an instance of that class, an object. We have 4 categories for methods, for responsibilities. This is really important. So pay attention. We have the creators, the constructor. We have readers, methods responsible of reading or accessing data and returning it. So we have the getters. We have delete methods, methods responsible of taking out data, of deleting or destructing data. In other programming languages like C and C++, we have destructors. In Java, we have the Java garbage collector, and that's an element happening in the Java virtual machine that is actually removing and destroying the data that is not used anymore, data without associations. Here it is not common to have destructors for classes because the Java garbage collector. But when it comes to methods, for example, remove an element from a list, remove an element from an array, something that we're going to use later. Yes, those are methods that come to be part of this category. And we have the U referring to update. All methods that are updating, modifying data belong to this category. So we have the CRUD. This is important because when it comes to talk about software development, you get to refer to CRUD operations. So those CRUD operations generally refer to the getter, staters, constructor, and destructors of a class. So, coming back to our big UML, we get to talk about the class agenda. The class agenda, something that is different, let me move over here. Something that is different is that in this class we have associations. Associations are referring as attributes. They are not attributes, properly speaking, of the class, but they are the relations, how we are associated to other classes. So here we see friend 1, friend 2, and friend 3, and these 3 elements are of type friend. So it means that those are objects of type friend, or objects that belong to the class friend, and it means that these objects share the properties of a friend, a name, an address, and a phone number, a part of the friend's responsibilities. We see, well, number of friends, this is the attribute corresponding to the agenda, and the 3 relations. So these 3 elements of the UML here are represented here. You see? That's it. We also have the constructor. So, I want to be clear that here I cheated in the constructor because I gave you the new friend corresponding to the 3 friends that come from the context. So we have Miguel, Laura, and Alex. This data here is totally fake data, but I wanted to show you how we get to create an object from a class. We call the constructor and we say new element of type friend. So when we call the constructor, if you get to remember, let me show you here. The constructor doesn't have any data type referring to the return statement, and there's not void either. So what happens here is that this method, as a constructor, is used to have an instance of the class friend. This is the way that we create the instance. It's going to be equal to a new object of type friend with these data values. Same happens with friend 2 and with friend 3. Whenever you find in Java, say, new method, constructor method, you are creating the object of the class that owns that constructor. Here we are creating an object of type friend. That's it. So this is something that I know from the exercise that I gave you. This is something that is not happening with these 3 specific friends because we are playing with logic and with selection instructions. But this is the way that I wanted you to know how we instance, how we create an object from a class. Let's continue. So, the relations, as we already saw, these relations are represented here. What does new mean? So, new is used to call the constructor of the class and to create an object from that class, an instance. Let's see what else do we have here. So, this is the constructor that we were talking about, and we have the new element of type friend, new object of type friend. And let's see this method that we have here. In this method, I particularly put it in these slides, is because this method is referring to the usage of a string and to concatenating strings. So, we need to return the list of friends. The list of friends is going to be modeled as a string, as you see here. The method is returning a string having in it the friends' names and phone numbers, as you see here in the description that appears in the Java doc. So, the first question that I get to ask, I don't want to play with empty seats. I already told you, it is really awkward to ask to an empty seat. It's like, if you see me in a public bus asking to an empty seat, the first question is going to be, is Pedro drunk? And it'll be like, I'm sorry, no, that's not going to happen. That's totally awkward. You don't ask to empty spots, you know? So it's the very first question that I need to ask is like, is this a spot empty? First question, if the spot, friend 1, exists, right here I'm telling that. So it is different from null. So if friend 1 exists, I'm going to add to my text the name and the phone number of friend 1. That's going to happen same. To my text, add friend 1's name followed by friend 1's phone number. And this is done asking friend 1 to give me its name. So it's like, my list is going to be added, or it's going to be complemented by friend 1's name. Hey, friend 1, give me your name. I'm Miguel. Oh, that's perfect. And friend 1's phone number. Hey, friend 1, what is your phone number? It's blah, 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 blah. That's it. This \n that we have right here, what it's doing is to create a line jump. So it is going to happen that after having this text with this \n, there's going to be a jump in the terminal, in the console. It means that the text is not going to be followed like this, but it's actually going to jump. I invite you to play with this code in the exercise provided for task 3 in the activity 1. And you're going to see the role of this \n. We, after asking friend 1, we come and ask friend 2. So, friend 1, thank you, get out of here. Hey, friend 2, do you exist? So if friend 2 is different to null, immediately we ask friend 2 to give its name and its phone number. If you see here, there is a difference in the syntax. I did this on purpose to explain to you that concatenation is something that can be used and can be following different manners. So the first one is referring to the previous state, complementing it with the next step. The second one is using plus equal. Plus equal is generally a way to say, I'm going to use this variable, list of friends, and I'm going to the current value of the variable list of friends, I'm going to add the upcoming data. That's how it is happening. We have friend 3. Friend 3, are you different of null? If friend 3 is different of null, I do the same. So in this case, look, we have another variable that is called list friend 3. And this variable is going to be equal, not plus equal. Look the difference. This is plus equal and this is just equal. It's going to be equal to the name followed by the phone number. So here, if you see the colon, is doing nothing else and nothing more than just putting a colon in the text. That's all. And we're using a method of the class string that is concat. So to list of friends, we are adding the list friend 3. At the end, we're returning the list of friends. I know that we have already, with this method, approached a lot of stuff. And don't be scared. Sometimes I know that coding can be felt scary. But no worries, because everything is going to be step by step. And I know that innerly you are understanding stuff that we haven't even covered, because this at the very end gets to be intuitive. Let me show you things that are happening here. So, we have a string list of friends. When we have a string list of friends equal to empty quotes, what we are creating is a local variable. A local variable is something that is born and dies within the method. This variable is going to be available within the method, is going to be useful within the method, but nobody else apart from the method is going to be able to access and operate with it. And as I told you, it's a variable that at the end disappears. So, variable here, what we're saying is we're going to separate a space of memory, and we're going to model data in that space of memory that we're going to label list of friends. If you see here, this list of friends is repeated here, here, and here. It means that everything that is within the method is going to be able to access list of friends. But also, it is important to notice that the methods operate in cascade, from up to down. So here, if you check, list of friends is initialized before any upcoming statement. That means that if I initialize list of friends after friend 1, here I would have an error, because list of friends is something that needs to be happening before it is being called. We initialize, we define the variable, and then we call and use it. That's how it works in this programming language. In other programming languages, for example, when you work with MATLAB, we have a different behavior. In programming language like MATLAB, you are able to initialize variables in methods used outside of the method. That's another approach. In Java, as you get to see in programming language as C++ and also as Python, it is necessary to define and initialize before calling and using. So, recommendation here, remember always that you need to define and initialize before calling. Here, this is the variable. Variable here, you get to see here, we are not using private nor public. It means that here we only care of this variable, which is going to be local within the method, for the method. And it doesn't need to be private or public, because at the end, it is born, used, and is dead within the method. That's how we're using. Here we have another variable, a string list friend tree. If you get to see here, it is defined within the if statement for friend tree. That means that if I wanted to use outside of this if list friend tree, it is not going to be possible to use it. It is being born and dying within this if statement. As same as happens with list of friends. So this list friend tree is going to be local for this if, as list of friends is going to be local for this method, as it appears. We already saw the \n that is used to bring jumping between lines for the terminal. My invitation is for you to play with it. Put the \n and take it out. And you're going to see what is going to happen visually. That's the feedback that you need to experience. I can tell you, don't be scared to play with the code. Nothing is going to happen to your computer, nor to a program, and at the very end, the idea is that you have trial and error while coding. Having errors, having to debug errors, that's normal for any programmer at any level, from amateurs to experts. Everyone is always in a continual process of debugging. So that's normal. Feel free to play with the code, to debug, and to see the extents. That's how you're going to build what we call the notional machine. So as we already saw, in this slide we covered strings concatenation, and that we are able, and we can do it in different ways. We access other objects' data requested them using the period, the point. So that's also something that we need to observe. To get the friend2 name, I need to say, friend2, give me your name. So it is requested using the point, the period. I'm calling the method that exists in the class friend. Same happens to phone number, get phone number. So I'm calling the method that exists in the class friend that is called get phone number. This is another way for you to play. Check if it is possible to access phone number as an attribute with a period from friend2. Check. You're going to see that whatever that is public is accessed this way. But if things are private, you are not going to be able to access them, as I have already explained before. So, this is the lecture, and we will continue. And yes, we're doing this amazingly. I want to congratulate you all for your participation in the Slack channel, also sending emails, also asking and responding. That's amazing, and that's the Gator spirit. So go Gators, and see you in the next lecture.